Hello everyone and welcome to Handmade Hero, the show where we code a complete game live on Twitch using no engines, no libraries. It's really designed to be a complete project from start to finish where we show how absolutely everything that is involved in the execution of a game, including the engine and the low-level rendering and everything, work at a very specific and fine-grained level. And right now we are in the middle of doing something which is kind of cool. We are sort of exploring how we want to handle the notion of 3 dimensions inside a game that is, using 2D art assets. And so we're kind of working out exactly how we treat that third dimension. And what's interesting about this is basically that if you make a game that's full 3D, then everything has to be represented fully in 3 dimensions, obviously, and it solves some things for you. It creates a lot of problems for you and new things that you have to deal with, certainly, but it also solves a couple problems for you, such as how you deal with height and things like this, because since everything is represented in 3D, you can just do full simulation on it and you get what you expect to happen out, right? And that's kind of nice. But in a 2D game, where things are not modeled in 2D, you just have bitmaps that represent things, you need to have some kind of semantic understanding of what should happen in terms of height. Because, to a certain extent, your game will probably have some limited interaction with that third dimension, even though it's technically a 2D game. And so, for example, the thing that we're looking at now is what happens if we want to put like a stairwell in the game? What happens if we want 2 levels of something where you can see down to the level below it, right? There are things you may want to do that involve a third dimension, even though the game itself is not 3-dimensional. And what we're doing right now is kind of exploring what our options are there and what it means for the code to do certain things there, so that we have a solid view, a solid perspective, pun intended perhaps, on that third dimension when we move into developing the engine, shipping engine code. Because I don't want to get into a situation where Z is always sort of haphazardly handled and sort of lumber towards the finish line of shipping the game with always kind of fighting how we're representing Z and hacking things here and there. I'd rather have a very solid conception of it if we can manage it, so that it's always handled very cleanly and logically in the game and allows us to do all the things that we might want to do with it. So that's what we're doing today. We're continuing that. We started that sort of earlier in the week, and we've sort of been slowly going through and going through different pieces of the code and seeing what Z means to them. And so let's go ahead and do that. Let's go ahead and continue doing that today. Now, before I begin, obviously, if you pre-ordered the game on handmadehero.org, you should have gotten a link in your email, and that link allows you to download the source code every day. So if you would like to follow along, today is day 75, so you're going to want to unpack day 74's source code, and you're going to want to start with that because that's what I'm starting with, day 74, yesterday's source code, here on day 75. All right, so let's sort of recap a little bit, and let's think about where we were. We had just finished doing some stuff where we were working on going up and down stairwells, and how we decided we wanted to implement that yesterday was you know what, I should make a new one for our day 75. Day 75. So what we had decided to do basically is, if you imagine looking at, so we'll do a top and side view. Since this is 3 dimensions, we got to kind of think about it in terms of a full 3 dimensions. If we have something like a stairwell, and our stairwell is, it goes up this way. So basically you'd imagine this is the bottom stair and this is the top stair of our stairwell. You could also think of it as a ramp. The way we had chosen to implement it, and if we were going to do it perspective, you could probably imagine it looking a little more like this. Right? It gets bigger as it goes up. Something like that. So if we're going to go up this stairwell, what we decided to do is, well, when the player comes here and they hit the stairwell, what we want to do is say that the player's Y location relative to the stairwell, remember this is the Y axis here, their Y location relative to the stairwell, as they move from here to here, as they move sort of in between these two, we're going to adjust their z height, where we believe them to be in z, so that they travel smoothly up z until when they get to the end, they're at they're at a particular z height, which would be the next floor, right? And same thing happens when you travel down the stairwell. You'd start at the maximum z height and go down to the lowest, right? So if we took at this as a side view, you would imagine it looking like this, right? And when the player comes in here, when the player enters into this region, we then say, okay, they're entering into the stairwell region. So now as they move from here to here, what we're going to do is adjust that ground height to be proportional so that it kind of, the ground kind of goes like that in between here. Now what we haven't done yet is actually move them down to the stairwell. What we actually did was let gravity, which we actually always apply, just pull them down eventually. But what that means is that if you come very quickly off of the stairwell, you actually don't go down, you kind of curve like this, right? You kind of do that. Which means technically you could actually jump the stairwell or other things like this if you're running at speed. I don't know, it's a little bit janky there. So that's probably not the way we want to do that, especially the speed of the player right now and their size and so on are not calibrated quite to human scale, so they actually get a lot more momentum than they should, and the stairwell's not very large at the moment, although maybe we need to change that. So there's a couple of things we want to do here. There's one other problem that we had was basically our movement scheme was a little bit janky too. The way that it worked is it constantly moved you underneath the ground and then projected you back up to the ground, right? That was our less than zero thing. And what that meant was that when you were approaching the stairwell from the other side, you constantly were below it and then get pushed up, below it and then pushed up, below it and pushed up, like that. Which meant that technically, if the stairwell wasn't larger, if the stairwell doesn't extend down this far, we wouldn't actually ever be placed inside it. And that was a bug as well. And so we need to start thinking about how we want to handle those things a little more cleanly. Just some things we need to think about in terms of actually getting this handling into some better shape. The other thing that we need to think about in order to get this working properly is we need to think about entity z-bounds for two reasons. We've got collision detection. So right now our collision detection operates only in 2D, which means that as you move, if something is below you, you will still hit it, or above you, right? And so what we need to kind of do is we need to do something where we're actually excluding things that are above or below you from hitting you so that you can pass under them or on top of, over the top of them. And we also have to do something where we put in, excuse me, in addition to collision detection, we would like to be able to put in something where we, draw more reasonably. Because right now what happens, well, you can see what happens. Basically, we have two floors stacked on top of each other at the moment, and wait a minute, we didn't recompile. We didn't recompile yesterday. We had turned off the two floors because someone had asked a question. So let's do that. There we go. You can see what happens when we have two floors. Basically, you just get them stacked on top of each other. It doesn't really make any sense. It's hard to parse visually. And so we need to, we haven't written the renderer for this game yet, so it's true that we, in our placeholder renderer, we probably won't be doing very much with respect to making this look pretty, but we should at least play around a little bit and just figure out what the plan is, right? We want to have some idea of what we're going to do when we actually have that real renderer. We need some clue here, right, as to what's going on. And so we need to think about that a little bit as well. Okay, so that's really what's going on here. We've got a lot of stuff to deal with, so let's start taking these one at a time. So the first thing I would say is let's go back up to the stairwell situation and let's think about that that ground aspect of it, right? let's try to think about getting this stuff worked out a little more solid. Let's think about not having the player go into the ground and pop back up and stuff like that. Let's try to do something a little bit better here. So the first thing that I might suggest, you know, it's again, I don't know because I'm sort of exploring this on my own here. I don't generally write 2D games. I don't know that much about how I prefer to handle things yet because I haven't ever really tried it. So I'm actually doing that experimentation and showing how we work through stuff like that in the real world. When I'm coming in here to my move entity call, what I'm thinking is that in general, we want to sort of do what you would actually have happen in reality. Excuse me. It's allergy season now. I am not sick anymore, but my nose keeps running. I know it's gross. Anyway, so what I'd like to do is have it so that perhaps when you are standing on the ground, you do not accelerate into the ground, right? So that basically that normal force when you're standing on the ground keeps you from accelerating into the ground, so you don't get that dip down problem. You just go straight across, and it's only when the ground is below you that you actually get acceleration from things like gravity. That would be nice. And so in order to do that, I think what I'd like to do is really use a little bit of energy storage, perhaps like a flag that says whether you're standing on the ground at the moment. In other words, at the end of the last time step, were you standing on the ground? And if you were, then I'm not going to apply, right? I'm not going to apply that gravity here. Does that make sense? Just something really simple. And we could do the check. We could do an overlap check again, but I want to not do lots of overlap checks if we don't have to, because you know, it seems wasteful necessarily to do them at the beginning and end of the frame. And so, you know, it probably is good enough, I think, since we're not a game that's heavy on using Z. I think it should be fine to basically do some kind of a quick check that looks something like this. So let's say that we were to introduce a flag here, which is like entity flag on ground or something like that. And that on ground flag is just saying, or like supported by, or we'll just say supported maybe, or you know, vertically supported, something like that. I don't know. Z supported, how about that? So if it is supported in Z, then we'll just say that gravity is not applying right now, right? So we'll say, you know, we'll do that as a flag check, which is just our isSet call. So on this particular entity, if it's Z supported, we would not add gravity. And if it's not Z supported, then we do add gravity, right? And I don't know, we could make the flag sense be the other way around. I'm not sure how we want to do that, but it doesn't really matter for now. We can always flip it later. It's not a big deal. So then when we come in here, what we want to do is say, all right, any time that this triggers, right, this pretty much tells us whether or not we want that flag set. If you've hit the ground, if you're going into the ground, that means you're Z supported, right? So what we want to do is we want to clear those flags, right? So we want to clear that Z supported flag anytime you've hit the ground, because that means you're standing on the ground now. And anytime that, oops, I have that the other way around, sorry. What I meant to say is you want to set the flag when you're Z supported when you hit the ground. And anytime that you're not, when you're in free fall, you want to clear that flag that says that you're Z supported, right? And so that'd basically be a quick way to sort of say, yeah, you know what, we're just going to sort of remember that, and we won't let you like kind of keep dipping into the ground. We'll coast you along the ground properly this time, right? And let's take a look and see if that fixes one problem that we had, which is right here. You remember I did a to-do where when we added the stairwell, we had to make the stairwell larger than it should have been in order to make that work. So let's take a look at that briefly. So of course here we've got the thing where we can go up the stairwell like so, but let's go ahead and see what happens if we take this out temporarily. Let's let's see here. Still no dice. So let's take a look at why that isn't working now, because I think that should work for the most part. Let's take a look. Of course, we still have it's still not quite what we would want in terms of collision technique, but I believe we should be able to get this to work properly, and I'd like to make sure that it actually does. Let's take a look at the hero specifically. Well, I guess I can do that this way, perhaps. Can I? No, I guess I would have to step, yeah. So I'm going to have to set a breakpoint on the hero specifically. And I guess, you know what? What I probably should do is give myself an easy way to do that, now that I think about it, so that I can always set a breakpoint in here. So I can basically say, okay, if entity type equals entity type hero, there you go. So basically, that's a trick I like to do debugging-wise, where I just set all kinds of weird conditions or whatever I want. You know, stuff that would get compiled out, certainly, so it doesn't really cost you anything because the compiler will eliminate this as dead code in an optimized build, but it gives me in a debug build a way to stop on a certain thing. So when the hero's moving, I can just say, oh, okay, let me go ahead and see what happens to the hero's movement. So when we come through here now, I can take a look at that overlap testing, right? First of all, what I would like to do too is I'd like to see if that flag is actually set. So let's take a look at, oh, well, I guess what I can do is just look at it here. Yeah, so it skips gravity as it should. And if we look at the DDP, its Z is 0, so that's good. And if I look at its entity position, it's, oh, that's odd. Why is its X, Y, and Z all 0? Doesn't that seem odd to you? Why are the X and Y's equal to 0? Have I not moved the guy yet? He's like way up here. Oh, because we always move the camera. I forgot about that. We're not in room locked mode. We're actually always moving the camera. So the player is by definition always at 0, 0. That's where he's supposed to be because that's the center camera point. Okay, so that's fine. Oh, that's interesting. But now it's not. Huh. Ah, I see what our problem is. So we clear that flag when we're not under the ground. So that's not quite what we wanted. If you're still on the ground, we do want you to actually consider yourself Z supported. So really it's less than or equal to the ground. Yeah, that's a bit of a mistake, admittedly so. Okay, so let's try that again. So let's see. Now we should be here, and now we can actually go in and find out what's going on there. So we don't add in the gravity, which is what we expect. We come down here. We don't really need to look at the collision routine. We need to look at the overlap routine, and we need to take a look at what happens during that can overlap. Now, in can overlap, I'm wondering, I thought I set a breakpoint here before, and yet it didn't ever hit. So I'm wondering why that was the case. Okay, there we go. I guess that must have been just a trick of the eye. So when we're actually going to look at what happens when we have a hero and a stairwell, right? There's the hero, there's the stairwell. When we actually do those tests, I want to know why we're not actually getting that overlap to occur here. So let's take a look. First of all, let's take a look at our two rectangles. So here's our entity rect, right? And well, you know, our entity, it doesn't help that our entity has no height to him. We should probably fix that. That's one of the things that we want to do today, probably too, where we were talking about, you know, having collision detection be properly three-dimensional. So the test entity rect. So okay, so basically the problem is just our stairwell actually doesn't extend down to the floor, which I'm not exactly sure why that is. It looks like it doesn't have any Z at all. It has no Z depth whatsoever. Why is that? That's real odd. What am I missing here, people? Do you know what's going on there? Did we not? We didn't ever give him a Z depth? The stairwell? Really? What? I'm so confused now. I thought for sure we had done that. Did we accidentally delete a line here? Did I like errantly delete a line? That's just crazy. I thought for sure that we had typed this in there, and I guess we didn't. All right, well, that's the problem. Obviously, you can't run into the stairwell if it doesn't actually contain the region it's supposed to contain. Oh, so I must have just done it. This is how tired I am. When I came in here and deleted the to-do, and we had that, did I just delete the whole line? What? Unbelievable. This is why we need to always have almond milk, people. That's just totally unacceptable. Anyway, let's take a look now. That whole thing where I can keep going upwards by jumping is kind of bizarre. And since our Win32 platform layer is, kind of a stand-in, it also does this thing where it'll lock down if you, yeah, it's kind of amusing. We should probably fix that, at least temporarily. Anyway, when I go on here now, it should work. It does. So that's what we were expecting. And so now we want to take a look at that part where we kind of float down it as well, and instead make it so that we rise up it more correctly, right? So we want to make it so that going up and down is instantaneous, and you can see how I kind of float down. Going up works properly because we're always sort of forcing ourselves to do that properly by having the ground be a hard constraint, but we're not putting ourselves back onto the ground in the case where we were touching it before. And so what I'd like to do, I think here, is say, okay, if the entity was on the ground, I'm going to say that we've got another criteria for when we want to stay pegged to the ground. What I want to say is if you're underneath the ground, or you had that flag set, right? The entity Z supported flag is set, right? And so you were on the ground to begin with, and you were not trying to go upward, right? So, and the entity, your entity DZ is equal to 0. So you were not trying to accelerate yourself. Then I'm just going to say that we're going to place you flat on the ground. So if you're on the ground, you stay on the ground, right? Because I think that's mostly how we want we don't really want the player jumping. The fact that we have a jump in there is purely sort of arbitrary. So yeah, if I walk up, it should work now, and if I walk down, it should work now as well. And it does appear to. Unfortunately, this familiar, I might have our familiar take a chill. He's making me kind of annoyed by following me around quite so much. Let's take a look at his update call there, so that I can stop running into him all the time when I'm trying to test other stuff. Familiar. Let's just say that the familiar doesn't actually find a hero ever. There we go. That's just not something he does. And he can just stay there. Thank you. There we go. So I walk up the stairs, I walk down the stairs, up the stairs, down the stairs, up the stairs, down the stairs. So that seems fine. I think that's working properly now, right? And again, we don't really have any rendering for our stairs, so that's a bit of a problem, but what are you gonna do? I think we're in good shape there. Yeah. Yeah. So what's going on? That's a little, oh, right. So now we also have one more problem to deal with, which is we have to start thinking about the other part of the stairwell that I talked about yesterday, which is basically, if you enter the stairwell, if right now wherever you are on the stairwell z-wise, right, determines your height. So if you enter the stairwell at the very top, you just slam right z up, right? If you touch the stairwell at the top, you immediately go up to the top. And I assume what we want to do is make it so that isn't allowed, that you just bump into the stairwell at that point. I don't know. I'm not sure what we really want to do. Maybe you do want to just slam up to the top. Maybe that's better for gameplay, that you don't have to think about stuff like that. I'm not sure. One thing I would like to do is I'd like to make the stairwell a little bit longer so we can kind of, think about it a little more easily by looking at what sort of happens when you touch it. So I'm gonna go ahead and say that maybe it has a little more height to it. So this is going to be like 2 tiles long or something like this. And I'm going to try and place it a little bit lower as well. So we'll say tile Y is 7 or 8, something like that. Or not. What happened there? Tile Y. Is that something weird that I've done by saying, oh, tile X, tile Y. Is there some reason why that was unhappy? Let me find out. I don't feel like it should have been, but it was. Why is it unhappy about that? I'm not totally sure I get it. Tile X equals 10 and tile Y equals 7. Because it should be okay to do that. Oh, because, well, no. So I'd like to know what's going on there. So shouldn't I be able to move this? Oh, I guess that would move it up. So I actually wanted it moved down, I guess, to be clear. And maybe even a little bit more down than that. Yeah. All right. That was because, it was because of the should door part. It was because it was actually trying to put it on top of the door, which we were not allowing at the time. So I guess I also want to, when I add the stair, I don't need it to be so fat either. It can be, just 1 tile wide, like so. Okay. All right. So now that we have a longer stairwell, right, we can kind of see, you can kind of see the guy walk up it. And when you get to the middle of it, it switches Z levels, right? Basically, this yellow blob just represents where our stair is. And that works pretty reliably, actually. That's pretty nice. And so the thing that I was talking about is the fact that, okay, I'm on the bottom level right now. I touch the top, and I just teleport right to the top, right? Which is exactly how we've designed it to work. I feel like conceptually it's weird. But yeah, I don't know gameplay-wise what we want to do. Do we want to just have you hit it? I suppose we just want you to be able to, you just want to stop there and not go. And so I'm trying to think, probably the easiest way to do that is to actually have stairwells be built out of multiple things that block you, basically. Like what I'm thinking is probably the easiest thing to do is to say, all right, the construction for a stairwell, right, is an entity, that's the stairwell, and then 2 other entities that are like, something like this, where it's like there's an entity here that blocks you from passing under the stairwell, right? And there's an entity here that blocks you from passing over it, something like that. That would still allow you to enter in the middle of the stairwell, and I'm worried that if you were all the way, if you did something like that, that the player would hit its head on it. So really you'd have to also make them so that they were kind of, that they were like this. I don't know, but we could do that. We could basically make invisible walls, right, that are just right on the sides of the stairwell. And to be honest, I don't really know if there's any real reason not to do that. I don't know. I'm a little conflicted. It's hard to say. I don't know what the easiest thing is to do. Because it seems weird to overload the stairwell handling and make it so that they have special kind of consideration for that. but we could do that as well. So let's think about how we would do that. So let's say we wanted to make it so that when you moved onto the stairwell, you just couldn't change your z height too much, right? Like let's say that we did it so that inside move entity, right? Inside move entity, what if this were actually something that were done that can deny the move from actually occurring, or something like this, right? Like we could decide that this is actually done, say, every collision iteration. I know that seems a little weird, but we could do it, right? We could do essentially, you know, this sort of thing, where inside the loop, every time, we actually go ahead and take this as an advisory P. Like we say, you know, this is actually like a test P that we're not sure if we're going to do yet, and we use that instead or something. Or basically like, well, no, you know what? No, I take it back. We can't do that because we would still have to check for collision with the stairwell and stop you when you hit it, right? So, yeah, I'm just really not sure. I guess one way we could do it would be to say that when you were going to collide with the stairwell, we'd look at what your height would have been and allow you to pass onto the stairwell if the height difference was small and not if the height difference was large. And the way that would have to look is basically the can collide after you do the collision here, right? After you do this, these these results here would basically have to actually do the ground computation for the stairwell, sort of right in the actual collision routine. And I don't know. It's not hard to do. I'm just wondering whether it's the right thing to do. But that would solve the problem, right? I say. And so just to give an example of what that would look like, let's just go ahead and type it out. So to give an example of what that would look like, essentially this stuff here would have to be sort of speculative. So it'd be like test wall normal, right? And test hit entity, like so. And these would actually be done like this, right? And so in the case where we actually find one, so if we do hit something, then what we would do is we'd create that speculative P. So it'd basically be like test P. This is where you would end up for this hit. And it's the test. We need to do it on the tmin as well. So test, tmin test was tmin. This is tmin test, like so. There we go. So now we're doing the collision entirely speculatively with speculative variables. We then say if we would hit the entity, then we create that sort of speculative point that we would have ended up at. Oops. Equals entity P. So that's the point we would end up at during this collision. And then what we can do after we do that test is we can actually have logic here, right? So we can say basically if that's okay, you know, then go ahead and actually do it. So if that's okay, we will then do an assignment that takes these guys and actually makes them the permanent ones, right? So hit entity becomes hit test entity, wall normal becomes test wall normal, and tmin becomes tmin test, like so, right? And so that allows us to do some kind of a thing that's like, you know, speculative collide or something like this, and that passes the entity and the test entity, like so. And that would allow us to actually figure out whether you were allowed to move on to the stairwell there. It's a little janky, certainly, you know, but what are you going to do? some things are janky, and we can sort of think about it as we go a little bit more carefully. So if we did this, I guess we've got essentially this going on. Like that. Yeah, so we would really just do exactly this, and we would sort of say, all right, this is the ground level on the stairwell, and we would then say, for the ground level, if the player, you know, would not be trying to go up too much when it hit this, when it hit the stairwell, then, you know, that's fine, right? So we'd say if the entity Z is if the entity Z minus whatever that ground level is not, you know, is not onerous, let's say. So we'd basically say if the absolute value of the difference between them, let's say, is less than whatever our step height is, right? So whatever we want our maximum step height to be, and you know, the step height is some random value. I don't know what we want it to be, but you know, 1/10 of a meter or something like this. Who knows? If that's okay, then you can go up it. If it's not, then you know it's not. So then we would say, all right, here's the result. We assume that it's fine. And I guess we would say if it's over the step height, then it's not fine, because in general you're allowed to move, but in the case of a stairwell, it rejects the move if it would be too high. So that puts us, if we wanted to do that, that would allow us to jump into there. That puts us squarely in the camp, again, of sort of, you know, wanting to be able to handle those pairwise collision rules, because if I remember correctly, our stairwells are set to not collide. They are only an overlapping operation. And we could get rid of the overlapping operation on stairwells entirely at this point by adjusting the player P in here, which is probably what we would want to do, so that inside the collision iteration it would adjust your position as you moved up the stairwell. Yeah. So, excuse me. Although we'd still need the overlap testing, never mind, because you'd need to overlap as you go. We just want to handle that in and out case. Yeah. Yeah. And so the stops on collision, we wouldn't ever actually stop you on collision either. We would let you just pass on through. So the stops on collision, let's go ahead and take a look there. I guess there's another kind of weirdness. There's one other thing that we don't handle here. Oh, this is, man, this stuff is tricky. If you actually want to do somewhat fancy 3D handling, there's so many things to think about. But it's interesting. I'm kind of enjoying trying to figure out exactly how I want to do some of these things. Anyway, so if we want to do our stops on collision bit here, then when we do our handle collision, we would also want to say, oh, we don't stop you if it's a, you know, if it's a stairwell, right? Entity type stairwell. So basically, anytime it's a stairwell, you're allowed to pass right through it. So stops on collision equals false, right? But we would then need to change our stairwells to be things that you actually can collide with, which right now they aren't. They don't have a colliding flag set on them, so we would need to add that to the stairwell, and then there we'd go. So let's do it this way, so on. Test undeclared identifier test. Well, that's true. It certainly is. It's supposed to be team-in test times player delta. I changed the wrong thing there. If test hit entity, potentially undersized local variable, that is true. That should be 0. Thank you, Mr. Compiler. Speculative collide must return a value. That is also true. All right. Let's see what's going on here. So we can still walk up and down the stairs, which is good. But the question is now, can we walk into them at the top? And we can. So that's not what we wanted. So why is that? Oh, because I didn't restart the game, so it didn't have that flag set on the stairwell. All right, let's try that again. So I can walk up and down it, but can I walk into the top? I can. So we're still bogus there, right? Because that shouldn't. We don't want that to happen. We don't want to be able to do that. So let's go ahead and see what's going on there. First of all, let's see if we ever actually trigger this, which hopefully we do. So let's go ahead and walk to the top part. All right, so we're never actually doing that hit. We're never actually hitting the stairwell. So that is the problem, obviously. Let's find out what's going on. So is there something? Okay, so there's our problem. We still had a check in there that said basically we don't want to actually collide with stairwells. There we go. Let's remove that. All right, so now we are colliding with stairwells, but it looks like we're checking in the wrong. It looks like I put the check in the wrong way. What did I do? Let me. We almost implemented that correctly. Boy, it is a. This is why you don't program when you're sleepy. Okay, so yeah, I just had it backwards. So basically what we want to do is, the result is, did you collide? And the answer is, you collided when the step height was too high. So that's what we actually wanted, right? So now we should be able to walk up it, walk down it, but we can't walk into the top of it, right? That's not allowed. So that's good. That's all very nice. And presumably we can only walk in at the very bottom and top. So that actually works quite nicely, actually. The only thing that is, we're not gliding along it, so we still have some weirdness there that I'm not sure. I'm not sure exactly what's going on with that. Why are we not gliding? So speculative collide. Why can't we glide along this entity? Like, shouldn't this be taking care of that for us? What am I missing here? What am I missing? Did we break? Did we break gliding entirely? Well, it looks like we don't collide with walls now, so that's a bug. Oh, right. So I guess speculative collide actually is generally true, and this is more of a only for stairwells kind of a thing. Yeah, sorry about that. Like I said, sleepy programming, not the best idea. Our speculative collision thing was making it so that all collisions don't work. So we're gliding properly still along other surfaces. So I wonder why we can't glide. What's special about the stairwell? I guess it's the thing where speculative collide is, because now in all cases they're still going through here. So what's the problem? Is it something with our handle collision call? I guess stops on collision equals false. That's probably what our problem is there. Let me think about this. So once you are on it, it would pass. So I guess we don't want to have you hit return stops on collision. We want it to actually, yeah, there we go. So there's that gliding. Yeah. So I feel like these collision routines, they just have too many weird predicates and stuff in them, right? That it's hard to, like, you see how hard it is for me to keep track of all of the predicates and where stuff happens. I feel like it'd be nice if we could kind of unify those and or make them into some really nice orthogonal unified set. What I will say, though, is I kind of like this way of handling the stairwells because, man, it feels perfect. Like, just playing with it here, it feels exactly like you want it to feel. In fact, despite the fact that our graphics are awful because we're not rendering anything, this is the best feeling stairwell I think I've ever felt in a game. I mean, that just feels great. Instead of like triggering some canned animation or just flashing, that you really like go up it. It just feels awesome. That's all I can say. Yeah, I feel like when we combine that with some good rendering for, you know, when there's actually a stairwell there and it's, you know, occluding properly and whatever, that's going to be pretty awesome. Yeah. I'm a fan of how we did this, is I guess what I would say. Yeah, that's pretty cool. So the next thing I think we need to tackle here is we need yeah, I'm sorry, I'm really enjoying this. It's really nice when you actually spend some time to do something and then it comes out good. That's really good. That feels fantastic. Yeah. Okay. Anyway, excuse me. We got some other stuff we got to do here. We got to do the 3D entity collision stuff. Obviously, that's relatively simple actually. But what I wanted to say was, first of all, we're going to put a thing on here. Oops, handmade.h. What we do want to do is for collision detection, I would like to say, can we do something about clean up predicate proliferation? Can we make a nice clean set of flags rules so that it's easy to understand how things work in terms of special handling? This may involve making the iteration handle everything instead of handling overlap outside and so on. So yeah, like I said, I don't really know, but that's something that we kind of it's just not perfect. So we figured out how we would go up and down. That's true, but we still have our how is this rendered. So let's keep that on there. And then we'll also maybe try to do the collision detection in the last 10 minutes here. The one thing I did want to say was z equals 0 for the ground. This is not right. You know what I'm saying? The reason this is not right is because that's totally dependent on where the camera was. Z equals 0 is just a camera location, right? And so what we'd rather do is have a notion that the ground is at a specific z-plane all the time. You know, and those z-planes are like stacked, you know, one on top of each other. So I'm not sure exactly how we would want to do that. Like, I'm not sure how we want to know exactly where the ground should be. But what I do think we want to do is say that for the sim region, that ground is actually a parameter, right? There's a ground level parameter. And what we're going to do here, or like default ground level, right? And our sim region, we grab that out there. And so when we actually do the begin sim, when we take that world position origin in, we should compute the ground level, the default ground level, based on that information, right? So, yeah, so we would want to basically do the movement based on that. Now, there's a bit of a nastiness here. I guess... So I guess it's not really default ground level that we want as well. Because this is, bear with me here, because I think this is actually relatively tricky and I want to make sure we do it right. So let's say we have a sim region, like we do, and we have some scenario where we've got, you know, from a side view, we've got a hero who's up here, and this is, you know, what he's standing on. But then there's also another layer down here, and there's a Monstar, right? And the Monstar hero. And the Monstar is on here. For simulating these two people, their ground levels are different, right? This guy's standing on this ground and this guy's standing on this ground. And so we want to be able to handle those both in the same sim region because the gather may have grabbed them both. So we really don't want... it's not that we need to know anything about the... it's not that we need to know what a default ground level is. What we need to know is just how these are aligned. so that we can look at where the hero is and say, okay, what's his Z level that he's on? And look at the monster and say, what Z level is he on? So what we really need is some kind of a Z base that tells us where, you know, these slices are, and you are at some tile height, you know, increment off of the Z base at any given time, right? That's what I think we actually want. And so I think that is really what we should be doing. We kind of need something that's basically like a ground Z base, something like that. And what you would do is, to find out what your ground level is, right? You would take wherever you are, and you'd sort of truncate it down to whatever that new Z is, right? So your ground level, when we're trying to figure out what the place that would be supporting you underneath, your ground level is going to be about that, right? Your ground level is going to be telling you that information. So there's still one more thing about this. So let's say we have a stairwell. Truncation isn't going to work because when you walk off the stairwell, you want to snap to the closest one, right? You want to snap, and truncation will work for this guy, but it wouldn't work for this guy. So it would seem like stairwell handling would have to be a little smarter. Essentially, what we would want to do for the stairwells is say, when you exit a stairwell, we snap you to the ground level that you would be on when you walk off it. Because otherwise, it's never going to work properly. If we walked off here, let's imagine heroes can fall off ledges, which I don't think we want them to do, but just let's imagine that they could. So if a hero walks off here, what's its new ground level? Well, we don't want it to snap to, well, okay, that's dumb anyway, because if we were going to do that, we'd just probably put an entity here that was like empty space. Since we're not representing ground explicitly, we would have to represent empty space explicitly too. So that's kind of dumb. Forget I said that. So if we wanted to snap, I guess the thing that we would want to do is, let's say a hero's here and it jumps, right? Or the familiar and he's floating up here. We don't want him to snap his ground level to here. We want him to snap his ground level to there, right? So we definitely need to do truncation. When we walk off of a stairwell, on the other hand, we want to sort of snap up to the closer one at the top, which would fight the two, like these two can't coexist. We have a problem there, right? And so I'm just not sure exactly how to handle that cleanly, right? Without saying the stairwell has to be in charge of that special rule, right? Which is that if you're walking up the top of the stairwell, you snap to the next ground level. So yeah, it's pretty complicated. I don't know. I don't know what a good solution to that is, and we don't have a whole lot of time left. So I'm not sure what I want to do there, but I guess I'll back that out for now. And we'll say that is another to-do that we have to do. So in here we'll say, something like need to make a solid concept of ground levels so the camera can be freely placed in Z and have multiple ground levels in one sim region, right? So that's basically what we have to fix there. And I suspect we already sort of have a bug related to that, right? Yeah. So if you note, the familiar and the Monstar move up with us, which is exactly what we would expect because they get snapped up to Z equals 0, right? Because they are standing on the ground. And so we already have that bug, and and so we will know when we fix it, because those guys should stay in the same z level, right? If that makes sense. So yeah, so I think that's important, is I guess what I would say. All right. So that's all good, I think. Nothing particularly weird there. I do wonder, one thing I'm kind of curious about, I just want to try this, is what would happen if when we rendered, since we have a little bit of time left in the stream here, what would happen if when we render, we just reduced, by your z, we took your z depth and we used that to reduce your x and y a little bit, right? So what would happen if we said, okay, I'm just playing around here. When we go to draw stuff, right? So we do our, I'm gonna go just a little bit. I just want to try this. If we were in here and we just said, all right, we've got our piece drawing function, right? Our piece group, and when we draw our pieces, right? Let's see where we draw those. Here's our piece drawing code. We do this computation to figure out where we should draw them, and then we draw them, right? So we do like our ground point plus the offset and so on. So if we were going to take that entity ground point, this thing, I'm wondering what would happen if we took the x and y and kind of made it be proportional to z a little bit, right? So if we basically said something like, you know, z fudge equals, you know, 1.0 plus entity p dot z times some constant, which is however much we want it to affect things, right? And then we multiplied that entity px by that fudge factor, right? I'm just purely wanted to see what would happen if I did that. I'm just curious. So you can kind of see now that we have multiple planes of z motion, right? You see how like what's underneath me looks like it's underneath me now? Or I guess, you know what, now that I think about it, I am on the bottom one. So yeah, so I have to walk up to the top one, right? And I can't walk through this yet because we haven't done the 3D collision detection. But you can see, so since we wanted to look at that 3D rendering thing, I was curious what would happen if we did that. And we really need to add that 3D collision detection so we can see it better. But that's a good example, right, of something we could do rendering-wise that would make it so that it was easier to tell what was above and below you in cases where you could see through things. Yeah, so we'll talk about that a little bit more. I was just curious what would happen there. So I'm going to say that's a good thing to play with. Anyway, it's time for the Q&A. All right. Please prefix your questions with Q colon so I can see them. And we will go ahead with the Q&A. Let me put Q&A on there. But yeah, I'm gonna add that to our list here and say that under how is this rendered, zfudge. I was curious about that the other day and I kept forgetting to throw it in there, but I think it's good. I think we're probably gonna want to do something like that. Yeah, it makes it feel really pretty nice actually. I'm guessing the engine will manage arbitrarily high ground levels. Would you really want that? Gameplay such as projecting attacks to a monster below does sound fun. So I don't know what we'll want to do gameplay-wise, but I mean, basically the idea is just that I want to be able to support whatever we want to do in the game with the engine just to show how to program it. And so mostly that's what I was trying to make sure we did, was like always make sure that whatever we wanted to do with grounds and stairwells and holes in the floor and stuff would be cleanly represented in the engine. And so since this is our architecture pass, I'm trying to get that stuff worked out. And mostly it has to do with collision detection, right? Because mostly and collision detection and response, like how things move and how they hit each other. Because drawing wise, it's pretty simple. I don't think we're gonna have to do that much work for drawing it. You know, the Z fudge was pretty straightforward, right? So yeah. Why not use the X and Y positions as they appear on the screen for detecting sim regions? I'm sorry, I'm not sure what you mean by detecting sim regions. Yeah, could you be more specific about what the question is? I'm not sure I understand it. Should you also check the stair step at the top of the stairs? It seems like you can exit earlier than at the bottom. Yeah, so what we actually need to do too is you can exit the stairs at any time, which is not good, right? You're right. I should put that in there. The reason for that is because in this call, which is not in this file, where is that? Yeah, in Speculative Collide, the problem here is that what we're doing is we are only checking to see what happens when you are stepping onto the stairs, right? We're only checking the difference between your height and the stair height. If you're already on the stairs, we're not doing a check at all, right? And we would want to. So what we'd want to do is see what your Z would be when you step off and checking that. And that would have been way better, right? So, you know, I can put a to-do in here as well. So you can basically say, we need a concept of stepping onto versus stepping off of here so that we can prevent you from leaving stairs instead of just preventing you from getting onto them. Yeah. So I agree with that. Could you please do an overview on Blackboard maybe of the entity's position system, world screen, etc. now that it's done? I'm having trouble understanding it. Hopefully you'll understand my question. It's actually pretty simple now. There's not a whole lot to it. So basically we, did we actually, you know what? Did we have this already? I'm trying to remember if this was before or after the whiteboard craziness got started. Or because I explained this once, someone asked that exact same question. Here it is. Is this it? Yeah. I think so. So I believe this is the diagram. I could be wrong. But basically what happens is we have a sparse world storage thing, and that sparse world storage thing stores the worlds in chunks that are non-overlapping. So they're just little basically like chunks of the world where we know there's some data. And that basically is just a way of allowing us to store as large a world as we want in terms of dimensions, while still only paying the storage cost of places that the world actually exists, instead of having to, if we were allocated as a giant array, it would be too big, right? So this allows us to have like long, thin, you know, sort of spirally, whatever, crazy paths through the world, and not have to worry about anything when we do that. So anyway, we store it that way. And then what we do is we gather, anytime we want to do a simulation, we pick some point in that world to gather around, and we essentially construct a box, a three-dimensional box of all the entities that all the geometry, the entire region we think wants to be simulated and drawn together. So we grab that out, and there's some part of it is what the camera is seeing at any given time. That'd be like this here. But there's a larger region that's actually being simulated. And what we do is the entities in here are stored positionally as wherever they are in terms of their tile chunk. So whatever chunk they're in, plus an offset in that chunk. So it basically says, like, I'm in this chunk and I'm this far from the center of the chunk. When they're brought into the sim region, we translate that into a position that's centered around whatever that center point is of the sim region, which would be right in the middle of the screen in the terms of a sim region we're drawing. If it's a sim region that we weren't drawing, we're just using to simulate, it's in the middle of the box, right, that's being gathered. So all of their positions are then just stored as simple floating point three-dimensional offsets from the center. We do all the simulation work there, and then at the end we write them back into the world by updating their chunk position. If they've moved to a new chunk, we remove them from the old chunk, put them in the new chunk, and either way we restore their offset to represent their new location relative to whatever chunk they're in. And that's about it. That's really all that happens. Why is the order of stuff drawn on the screen janky? It's because we aren't sorting anything yet. Isn't it easy to draw them in order? Each layer draws entities left to right, top to bottom. So it's not, you're missing one thing, which is the Z sorting as well. So it's not just left to right and top to bottom. It's actually Z plus Y. It's a little more complicated than that, but yes. And the reason is because we haven't sorted them yet. So until we write a sort, we can't do that, if that makes sense. So I don't want to bother doing that till we get to the renderer, because otherwise we have to start doing the renderer to put the sort into something, because we need to actually buffer all of the entities first before we can sort them. And so obviously I don't really want to do that until we actually start the renderer. Otherwise I have to do half the renderer to put the sort in, and then stop doing the render and go back to what we're doing. So since there's absolutely no reason why, like, I don't care whether the things are sorted, it's not preventing me from doing any other work. It doesn't seem like a good use of time at the moment. Is the reason why things in different levels seem shifted up due to the Z offset when rendering? Yes, it is. It is, and we can get rid of that too. Like if we could make it so that the entity Z was only used as an offset. So the shifted up bit is in here. It's this, right? So if you didn't want that, you could just do this, right? That's where the shifting up comes from. I think that's what you're talking about. So if you didn't want that, it would look like this, right? And that may be preferable. I don't know. Like I said, we haven't quite looked at that yet, but that's where that comes from. And then when you come up, you're still in the same shifting. So that's where that comes from. If that makes any sense. Will this cause for the wall on the top to be drawn above the screen when the camera is locked instead of following the character? Possibly, but I mean, we can adjust all that stuff. And don't forget, our wall stuff, I mean, we haven't really figured out exactly how we want to position those. When we do more world building, we'll kind of have a better idea of that. When you are allocating everything with custom memory allocators, do you only use the stack for pointers? I'm not sure I know what that means. You can still use pointers with custom memory allocators, so I'm not sure. I'm sorry, I'm not sure I understand that question exactly. Are you not worried that 3 dimensions might complicate entity AI to the point where it impacts performance? Not really, no. AI is pretty easily tunable, usually. Like, you know, if, certainly it have plenty of power to simulate, I think, the AIs that are interacting with you directly. And so the only question is what we need to do in terms of simulating other things, like large worlds where other things are going on. And so if that's the case, then I would probably say we'd just simplify it. We'd make a few concessions and do simpler AIs when you're not there, right? When you're not interacting with them, they do more. They do much more coarse-grained behaviors that aren't as complicated or something. So for people asking about the forum registration process, I have no idea what to do about that. Apparently, we get listed at Spamhaus for some reason. I don't know why. And then the registration emails don't go out. It's kind of an epic disaster. It's the standard thing. I absolutely hate the web and web development. This is a very basic, simple concept. But since, of course, the brilliance that is the architecture of the web can't even handle spam without ruining people's forums, apparently. And so I have nothing but negative things to say about that, and it's been a huge pain in the butt. So I definitely apologize to everyone who can't register, and there's absolutely nothing I can do about it, apparently, because that is how awesome the internet is at everything. What we really need to do is just create our own application that allows us to talk about Handmade Hero separately and just cut all these lousy programmers out of the mix. When will you switch back to centered camera? We don't know. That we've already demonstrated that both work, so I'm pretty confident we don't really need to test anything on there. That'll just be when we're making the game. We'll play around with how we want the camera to be aligned. Any particular reason behind making the chunk origin the center of the chunk rather than one of the corners? Not particularly. We had both. At one point we were using the corner. And yeah, I can't really think of any particular reason to use one or the other. I guess one reason is because it makes it easier to allow chunks to hold things that are bigger. Like, if you wanted to, you could allow things to be a little bit over the chunk boundary or a little bit inset. It's easy to think about where something is relative to the chunk center in that way, where it's a little harder to do that if it's a corner because then it's asymmetric. So centers might be a little bit more convenient for certain things, but on the whole, I think it's probably arbitrary, I would guess. Sorry for being unclear. Do you store anything else than pointers on the stack? On the stack. Meaning the thread stack? Like the stack, I mean, the stack stores all the local variables and stuff. I still don't understand. Tons of stuff is stored on the stack that's not pointers. For example, everything you see on the screen. Z-fudge would be stored on the stack, right? Piece index would be stored on the stack. All of these are on the stack, right? So I'm not sure. Still don't quite understand the question. If the camera were far enough away from the player, would the player go into a simpler routine like the rest of the entities? Well, the camera's defined to follow the player, so I don't know. That's really a case that could never happen. Should the possible collision test use the test hit entity instead of test entity, or are they the same? Can you briefly go over the flow of the hit entity changes? They are the same, so I can show you what's going on there. So test hit entity and test entity are the same in this case, always. The only reason that we have it being set to test hit entity is because there's another thing called hit entity, which basically, in fact, here's one way you could think of it. This could just be a bool. This is just a bool as to whether or not we hit. So for example, we could just make this hit this entity, right? That kind of thing. And then in here, we would just say hit this equals true, right? We're just trying to see whether we hit the thing. And then what we do is we say, okay, if we did hit this thing, then before what we were doing is we were just setting the entity that we hit, which is this what tracks is whether we hit something or not, is setting hit entity. Before we were setting hit entity in here because it meant that we had a hit and we would process it. But now what we're doing is saying, okay, if we hit this guy, the test entity, then let's do speculative collide first and see what happens. And then only if speculative collide says we should actually process the hit, then we record the hit as we were recording it before. So that's all that that's doing. It's just putting a layer in between the detection of a hit and the acceptance of that as an actual hit. And so these are just temporary variables to let us do that processing without actually recording it into the loop itself. Hopefully that makes some sense. I'll compile that. Let's just verify that that actually works. So there's that version working, right? And so again, all that is just before we were directly setting the entity that we hit, and so every time we got an earlier collision in our T testing, we would just accept whatever the earliest one is. Now we provisionally say, okay, we found an earlier hit, but we don't actually want to accept that as our new closest hit until we check speculative collide and find out that it's okay. Because maybe it's something we should just pass through, like a stairwell, when we're not trying to step onto it from too great a distance. So what we do need to do is we need to handle the stepping off case, right? And so that would also require us in here to kind of do a little more work. Trying to think, I haven't really thought through exactly how we want to do that, because it does seem a little bit difficult. But you know, that's just the way it is. I suppose what we would want, you know what? I suppose there is a way we could do this a little more easily. If you're stepping off the stairwell, we could just see where you were barycentrically on the stairwell. In fact, I guess technically what you could do is actually do it a different way. Instead of figuring out what the ground or the step height and stuff is, because we know this is only semantic handling of z, you could do this instead. You could say that the result is whether you're only allowed to step on the stairwell at the ends, right? So we could say our barycentric y, which is where you are on the stairwell in terms of where you were trying to step onto it or off of it. We could just say that that barycentric y has to be between, you know, the first part of the stairwell and the last part of the stairwell, right? If it's in there, you're not allowed to step on or off of it, right? I think that would work. Yeah, and that does work. You can see I can't get off of the stairwell, right? Of course, we have that problem of the stairwell's actual collision region needs to be smaller than the width that you draw the stairwell at, because technically we're only checking that internal part of you, right? So I don't know how we want to do that, handle that rendering bit, but that does fix that problem, right? Now you can't get onto the stairwell in the middle. You can only get onto it at the end, and whatever. So, I guess that doesn't. That also doesn't fix the stepping on at the end. So I suppose you still do need to know whether, yeah. So you still do need this. Basically, you would need to say, if that happens or this happens, either case is disallowed, right? And that would then allow us to do both. So now you can't step on to it anywhere there, and if you're at the top, you can't step onto it anywhere here. But now you also can't step off of the stairwell unless you're at one of the ends. So that's a pretty easy way to do it as well, I guess. So yeah, I don't know. This needs work, right? You could now cancel out the first hit this equals true and not do other checks. Oh, you're talking about, you're just talking about this kind of thing, right? At least I think that's what you're talking about. If that is what you're talking about, that's not actually true. Because if you look at what's happening here, we need to find the earliest collision. So it may be that one of these is going to be earlier. And so this test wall normal and tmin will be set to different values. So you actually cannot do what you were suggesting. You can't early out on this variable. You need to do all of the tests so you find out which wall you actually hit first, right? So yeah, just to be clear, you can't, that's not a valid optimization. That would actually change the result. All right. Looks like we are coming to the end of question time. Question time. Yeah. Yeah. Yep, looks good. We have come to the end of not only another week of programming on Handmade Hero, but we have done something that we have never done before, ladies and gentlemen. And that is agreed to go on break for a week. Now, normally I don't like going on break for a week from coding. I don't think I've ever had a week in which I didn't program something. That is absolutely crazy. I'm okay with it because I program every day for work anyway, so that's fine. But going on break for a week just philosophically from programming, I don't love. But people were asking for time to catch up with the series, and so I can totally relate to that. And I will be traveling next week, so it would be hard for me to stream the live stream anyway. So what we decided to do is we will do a little break here where next week we will not be doing Handmade Hero, and then we'll come back the week after. So basically, this whole week here, the 2nd through the 6th, we won't. And then on the 9th, on Monday the 9th, we'll be back with Handmade Hero. So enjoy the vacation. I hope you get some good programming done and whatever else, catching up on the series or doing whatever it is that you'd like to do. And I hope to see you back here when we resume. Until then, if you'd like to follow along, With the coding, of course, you can pre-order the game on handmadehero.org and download the source code. It comes with the source code every night. I upload it after we finish programming. If you'd like to support the video series, we do have a Patreon you can subscribe to, and that's linked off handmadehero.org as well. We have a news and forum site, which the wonderful architecture of the World Wide Web is doing its best to make sure never works properly. Thank you very much to Spamhaus for listing us as a spammer, even though we have never sent out a single email that wasn't for the forums. Literally, we don't even have a mailing list, and we got listed as a spammer. So that's awesome. Again, really solid web architecture. If you're wondering why I absolutely hate the internet and its code, it's because of stuff like that. Every time we try to do something, it's a disaster, and that is often completely out of our control. Anyway, that said, we do have some other good stuff on there besides the fact that they are breaking our forums, and that is that people have done community modifications to the engine and stuff to make it run on Linux and Mac and stuff already. Even that's not something that we've done. You can find those ports on there, and that's a cool place to check those out. There's also other resources on there, like an annotated episode guide, which is pretty cool. And when Spamhaus is not blocking your registration emails, you can also go to the forums and chat with other developers about the code base and so on. We also have a tweet bot that tweets the schedule, so if you want to know when things are happening, it obviously won't be tweeting anything next week because the series will be on vacation, but the week after it will resume tweeting the schedule. And that's, I think, everything. Obviously, we also have a video archive on YouTube, so you can watch all the old episodes there as well. So thanks, everyone, for joining me, and I hope you have a good week. I will see you guys back here, not next Monday, but the Monday after. And yeah, it'll give us some time to think about other stuff we might want to do with our Z handling. So thanks, everyone, and have a good week.